Today we're going to be talking about arcs and central angles. And there's a property that says the measure of an arc equals the measure of the central angle. So WOX, and we're going to assume that O is the center of the circle, is equal to 112 degrees. So that means that arc WX here is also equal to 112. Now, in order to get arc WYX, what we're going to be calling a major arc, and I'll talk about that in a minute, is you have to subtract from 360 because the circle is 360. So 360 minus 112, which is 248. Okay, a minor arc is an arc that is less than 180 degrees. So a minor arc would be, for example, arc AT. And we write it as AT. That tells me essentially the two endpoints of the arc and a little arc symbol over it. You could also talk about arc AC being a minor arc, because we can assume a semicircle is 180 degrees, so that would be arc CT. Or a better way to name that would be arc CAT. So naming that by 3 letters tells me that you're starting at C, going through point A, ending at T. So therefore, now let's talk about a major arc. A major arc's greater than 180 degrees. So that would be something like starting at A, going through T, and ending at C. So that would be, and we'd write that as ATC, where A and C are the endpoints of the arc, and T is a point that's in the middle. Because if I just named arc AC, we're going to imply that it's the smaller of the arcs. Or I could have named it CTA if I wanted. Adjacent arcs, just like adjacent angles or two segments that are right next to each other. Two arcs that are right next to each other. So AT, and TC would be considered adjacent arcs. TA and AC would be considered adjacent arcs. Now the arc addition postulate is just like the angle addition postulate or the segment addition postulate. That arc CA plus arc AT is going to equal arc CAT. Okay, finding each one of these measures. I give you one angle 63, one angle is 82, so I know this arc is 63, this arc is 82. We can assume NR is the diameter because it goes through the circle. Oh, and it tells us that they're diameters. Now get with the program. So MN is also 63, which makes this 63. 82 plus 63 plus angle POQ adds up to 180. So that makes this 35, labeling my arc to be 35. And then using some subtraction here, we have this arc up here is 117, or the angle is 117, so our arc is 117. So now it's just a matter of filling in. And I've labeled each one of the arcs so that we know. Arc MN would be this arc here, which is 63. Arc NQ is going to be 82 plus 35. NQ would be this arc here. So that would be 117. Arc NQR. NQR. Well, that's a semicircle, so that's 180. That one's easier. MRP. So let's do M going through point R all the way over to P. So that's this whole big arc here. So that's 117 plus 63 plus 35, that is 215. Getting a different color here, QR. QR, oh, that one's easy, 63. MR, hopefully MR's is easy. MR, 117. QMR now. QMR. So starting at Q, going all the way to M, all the way over to R. So that's most of our circle minus 63. So 360 minus 63, 297. Arc PQ, that one's easy, 35. PRN. P to R all the way to N. So this whole arc here. So it's basically 180 minus 80, I'm sorry, 360 minus 82. That's 278. And let me rewrite that just in case you're not able to see it. And then lastly, M, Q, N. So starting at M, going through Q to get me to N is another 297. Okay, this is probably one of my favorite questions, not only this semester, but maybe potentially the whole year. The radius of the Earth is 6,400 kilometers. The latitude of Columbus, Ohio is 40 degrees north. So from my equator, I go approximately 40 degrees north. And I need to find the center of this latitude. So this circle, the latitude circle, I need to find the radius of that circle. Okay. From the center of our Earth to any point on our Earth is 6,400 kilometers. Now, if I drew from the center of the Earth over to 0 degrees, that's also 6,400, but tells me that this angle, because our arc equals the central angle, that's 40 degrees, and that should be a degree symbol. Let's see, do I have enough room? Oh, nice. 40 degrees. From our center up to our radius of our circle of latitude, this is a perpendicular. And this is also perpendicular here. So that means this angle is 50. So what we have happening here is a right triangle, where I'm looking for the opposite side, giving you the hypotenuse. So that's the sine of 50 degrees is equal to the opposite over the hypotenuse. Make sure you're in degree mode. And R, I just basically did 6,400 times the sine of 50 in my calculator and got 4902.68 kilometers. There are your lesson questions. Please make sure your summary is submitted on time.